Okay, next question.
Okay, chapter 2.
Okay, chapter 2. Which question?
Chapter 2, number 2. The answer is donkey, right?
Chapter 2, number 2. The variation of velocity with time of a car traveling along a straight road is shown in the graph below. Which statement about the force acting on the car is not true? The net force acting on the car during the interval P.
Correct.
That is correct. Right? You want the wrong one because there's an acceleration, so there's a net force. And then no net force act on the car during the interval Q. Q uniform velocity, so no net force, correct? Opposing forces may be acting on the car during the interval Q. Yeah, opposing forces, they are in equilibrium. The magnitude of the net force acting during interval P is less than during interval R. Look at the gradient, no? The resultant force is the gradient, which is the resultant acceleration. So gradient of P.
I mean, P is small lah.
Okay with that?
Yeah, answer.
So the wrong answer is donkey.
Okay.
Next question.
C, the number 3.
A bus is traveling. We have done so many times with that. The bus is moving at constant velocity 20.
Sometimes I want to reimagine like a bit tough lah,
Where got
the
big tough?
graph.
We have done so many times already. I think this is the third or fourth time already. We have done go over with you. When you first came for tuition, we have done this question already. The same distance travel, that's all. We are looking at the same time as well. Same time and same distance. So the bus is constant velocity, horizontal line. Just as the bus passes the stationary car, the car accelerates. So the car is moving in a straight line. If you look at velocity time graph, what's the distance traveled by the car when it overtakes the bus? Both of them must have the same time. Distance traveled by bus equals distance traveled by car. Okay. So bus is constant velocity, so it's speed times your time. Whereas this one acceleration, that's why you use this formula. S is ut plus half at squared. Cancel the t. Put in your value. U is 0 for this part. V is 20 for bus. Half A you are told is 2. T squared. Cancel the t and then calculate your t. And calculate your distance. VT 400 meter. That's all. Okay. Okay or not?
Yeah, okay.
Next question.
Number 4.
A stone is projected vertically upwards from the top of the building. Which graph shows the variation with displacement of the stone with time t? Okay, so if you remember, it's projected from the top of a building, so the displacement will start to increase. So it's either A or B you need. Then the velocity, right? How to get from the graph? This one tell you it's uniform velocity, but velocity is decreasing. So the slope is decreasing. So answer is B. Right? Velocity is the gradient of tangent to the curve. Velocity decreases to 0 at maximum height. Yeah, maximum height at this part there. Velocity is 0. After that, the velocity changes direction, right? Negative, and start to increase again. And then after that, go below the building. Answer is B. Yep. What's the problem? Okay. Okay or not?
Just give me a minute. Okay.
Next question.
5.
A ball is released from P as shown in the diagram below. The time taken for the ball to travel from P to X is 3 seconds. If the distance between X and Y is 250 meters, what's the time taken for the ball to move from X to Y? So you have to find the velocity at X first. Right? You know initial velocity is 0. Take downwards as positive. Right? We want to calculate velocity at X first. Use that because you know A, which is your G, and the time is given. U is 0. Put in your value, calculate out. Now we want to look at X and Y. We know the distance. We know G. We want the time taken. So what is given? Your initial. Now this become initial already. Remember, this is velocity at X, so they become initial. A is 9.81 hours. S is 270 meters. You want to find the time. Then choose the right formula. Put in the formula. And then use your calculator to help you. Calculate the value. Cannot use a negative value. Use a positive value. Answer is always positive. So answer is just you want the total time, not the 5 seconds. Right? Total time, you just add the two together. The initial time and the time from X to Y. Yep.
Wait, the 3 plus 5 from where now? So it's from X to Y is 3 plus 5 lah.
From P to X is 3.
No, X to Y is 5. No. But why need to campur? Why not the answer is 5?
The time taken for the ball to move from P to X is 3. Let me just go.
No, but they only ask X to Y only, what?
Oh, yeah, right. But there's no answer.
So 8 lah. No choice.
The time taken from the ball to travel from P to X is 3. If the distance between X and Y is 270 meters, what's the time taken for the ball to travel from X to Y? Yeah, you're right. But there's no answer like that.
So answer, most appropriate answer is donkey lah. Maybe the question error it somewhere. They should have put from P to X to Y.
They didn't ask you the total time from P to X to Y. They want X to Y. So there's no answer.
Yeah, that's why. So the answer should have been 5.
Unless it's they use negative. Negative also cannot be what. Negative with 22. 22 divided by 2 is 11. Cannot be. The answer should be 5. But no answer. Okay.
Fair answer.
Okay, next question.
Okay. Number 6.
A boy releases a small stone from rest. From rest is initial speed is 0 at a height 50 meters from the ground.
S15.
That's your S. After 1.0 second, he throws
You get time.
small stone straight down with an initial speed. If the 2 stones reach the ground at the same time, what's the initial speed of the second stone? Okay, you can calculate for the first stone. You're given enough information. Thrown from rest, U equals 0, height is 15 meters. You want to find T, so the A is given, G is given, put in the formula, calculate out your T, that. Then second stone, same height, you want to find U, initial speed, time, you know, yep, time, but he throw it after 1 second, so the time taken is subtract 0.75. Since you take downwards, your G is still the same, 9.81. Same formula, put in your formula, calculate out. C.
Okay, teacher.
Next question.
7.
Aeroplane flies horizontally at a constant speed of 100 meters per second. It drops a parcel of food which lands forward on the ground at 600 meters. by neglecting air resistance, the height of the aeroplane from the ground is, right? Can use the same idea. Throwing a ball horizontally, the same thing. 100 meter, there's your horizontal speed. This is your horizontal distance. So from the horizontal speed and horizontal distance, you can calculate the time. Right? Consider horizontal motion first to calculate the time. Remember, it's uniform velocity, so it's x divided by u. Calculate out. X is 600, u is 100. So you got
Yeah,
a,
it's yeah.
now consider vertical motion. S equals to your h. A is you take downwards as positive, so it's 9.81. Your time you have to calculate is 6 seconds. And then your u is 0. Initially 0. Vertical speed is 0. Choose the formula. S equals ut plus half a t square. Put in your formula. Right? U is 0. S is h. Half a is 9.81. T square. 6 square there. That's your answer A. Okay or not?
Yeah, just a minute, Acha. Yeah, okay.
Next question.
Section B lah, Acha, the number 1.
A boy kicks a ball and the ball moves with an initial velocity of 25 meter per second at an angle of 35 is drawn for you to the horizontal. The ball reaches a maximum height before landing on the hillside as shown in the diagram below. By neglecting air resistance, calculate the horizontal distance x. So what should we do? Yep. What should we do?
Okay, we have the S is 8.6 meter. You have the initial velocity U is 25, and then
Yeah,
you have
calculate
an
x yet.
inclination angle 35. So 25 cos 35 lah.
Yeah, you cannot calculate x yet. You don't know the time, so you have to calculate the time first. So you consider the
Oh yeah, oh yeah. Oh yeah, we cannot simply do 25 cos 25. We need the time also.
You have to calculate the vertical motion first. Calculate the vertical component. Take outwards as positive. So you got your A, your G becomes 9 minus 9.81. Your height is 8.6. Remember there are two 8.6 here. One is the earlier time, one is the later time. And put in your value. Calculate out. Right? Remember, we want the larger value, not the smaller value. So we don't want the negative one. We want the positive, the largest value. Shorter time is for the first height, this height here. After you calculate the time, then use your horizontal component, no? Ux times t, horizontal component times your time. Calculate out. Can.
Why is it negative 0.81? Not positive 9.81.
Right? You are taking outwards as positive. So G is downwards.
Yeah. Oh yeah, G is against gravity, right? Basically.
Okay. In case we got cut off, we have to start a new Zoom. We got 10 more minutes.
All right. Okay.
That question?
Just a minute, Archer. Okay.
Question?
So the B. So B
Time
has
of,
to be
time of flight of the ball.
2.08 second lah.
Yeah. We have calculated already. Speed of the ball during impact. Right? Horizontally, we know. Vertically, we have to calculate out of counter vertical motion. Right? We know the vertical velocity negative because we take ours as positive. And then there's the time that we calculate. Calculate your V. V equals to ut plus half at square. That is your U. Your A is minus. And then that's your time. Calculate. Negative means it's downwards. That's the one. It should be downwards, not the upwards one. And then use Pythagoras theorem. No? Resultant speed, they don't want velocity, they don't want the angle. So they want the speed only, the magnitude. Okay with that?
Sure, go back again, sure. Okay. The next one, define acceleration. Acceleration is the rate of change in velocity.
Yep. Derive an equation of motion with the initial speed u, final speed v, displacement s. In a session, you want v squared equals u squared plus 2as. So you have to start with your definition. This is your definition, your equation. And then substitute into your, this one, these two equations, you must remember before you can derive it. Right?
Substitute in S.
Yeah, and then simplify. Can take the 2a across there, you got 2as. Then this your your v square minus u square. Take the u across there, you get u square. Can or not?
Sure, go back again. Okay.
Okay.
Wait. Yeah. Okay.
Okay. A driver is driving a car at 72 km/h. Make sure you change that to meter per second. Suddenly, a child runs across the road at a distance 30 meters in front of the car, and he brakes immediately. The driver's response time is 0.5. Right? That means during that time, 0.5, he is moving at constant speed. Determine the minimum acceleration of the car so that the child will not be knocked down. So first is convert your 72 to meter per second. Right? 72 kilometers is 1,000. And then 1 hour is 3,600. So during the 0.5 second, that's the distance he traveled. Right? Uniform speed 20 times 0.5. Then for deceleration, you got initial speed is 20, final is 0. Right? That's not the distance you travel. You have to minus your 10 meter. So it's 20. Then you can calculate your acceleration. So we use your v squared equals u squared plus 2as. Put in your formula and calculate. Yeah. Displacement time graph. Displacement is uniform velocity. After that is deceleration. So it should be a curve. Okay, no?
Just a minute, sir. Yeah, okay.
Tennis ball being hit.
It's all about sketching the graph, sir.
Sketching the graph there. Initially, it's uniform velocity, so it's a straight line. After that, it's not. It's a deceleration. Should be a curve. No?
Oh,
Parabola, the other
okay.
way around.
All right, okay.
Tennis ball being hit over the net is shown in the diagram below. Determine the initial velocity of the tennis ball or vertical component. Okay, you are given 1.0. You are given a distance. So you want vertical component. Look at the vertical motion. No need to memorize formula. Vertical motion. Initial speed is what you want to find. You take outwards as positive. So your G is 9. Your acceleration is minus 9.81. At the maximum height there, your velocity is 0. So your height is 1.0. Choose the right formula. V squared is u squared plus 2as in your formula. Then calculate out. That's your vertical component. Calculate the time taken for a tennis ball to land. Okay, so you can calculate the time to go to maximum height and then multiply by 2, or calculate all together. There's the initial component you have calculated. Final component is minus. What you go up must come down the same speed but different direction. And there's your G. You want to find your time. Use your V equals to U plus 80. And put in your formula. Calculate out. Then calculate your horizontal component. Yeah, horizontal velocity divided by time. Horizontal distance, you add the two values together, 11. Time, you have got that. Get 12.2. Then draw a triangle. That is your horizontal component, 12.2. And you got your vertical one 4.43. Then you want to calculate the angle, use tangent. No? You don't want the velocity, the magnitude of the velocity, you want the angle. That's all.